what drives our business. It's really what drives market share, creates quality products, all those ancillary things that we all care about as design engineers in our lives, and people outside of the nucleus of engineering, they care about, right? They want, how many times does quality control come to you and say, hey, we need the next generation, or we need it better, we need it smaller, we need it less expensive, right? All those things matter in our lives as design engineers. And I say our lives because I am a design engineer. I may not look like one, but I did get a degree. It's in my wallet, I'll show you later. I'm just saying. I told it around on purpose because I always get the question. But as a design engineer, we have to carry on our shoulders the concerns of other people, marketing, sales. Before it's even produced and before it's even out the door, sales and marketing is asking us, hey, can you give me a screen capture? I'm going to meet with the customer and I need the product, I need the product. And we're saying, hey, listen, I'm at the conceptual phase, lady. Back off. Yeah? But that's our lives, right? So today, we're going to talk about all the tools in the Autodesk product suite that really center on automation and help us as design engineers in product development make our lives easier. Now, there's a lot of tools in the Autodesk product suite, but today we're going to focus on some very specific things. So let's talk about the traditional design process. Everybody knows these four things that I'm talking about up here. Concept, right? Somebody comes with a problem and says, listen, I need you to solve this problem for this reason, because our customers are saying this and this and that. And our job is to design a solution to the problem, right? That's what we all do every day. Every day we're coming up with new solutions to this problem. Now, traditionally, you go from design to prototype, and then you test it. And then God, hopefully we get out the door. But it really doesn't work that way, right? And design engineers, I know I'm awesome, but I'm not perfect, right? My concept might not be the most optimized version of my idea. It may be good, but it may not be cost effective. It may be good, but it may not be safe. It may be good, but how do I know that once it gets out the door, it's not going to kill somebody, right? So all these are my concern. Now, where you see the most time and money spent, and where we're going to focus our time today, is prototype to test things. Now, us as design engineers, that's probably where we spend the bulk of our time deciding, okay, here's the prototype, what do the tests need to look like, what compliance issues do I need to satisfy, who above me cares about what I'm talking about, and my job area. Now, there are a lot of times when we can interject where we spend most of our time. Now, our role, the reason we went to school, is to be creative, right? We're creative beings, we solve problems, we solve challenges. But how many people in here spend like 50% of their time looking for the doggone data? Where is it? Who had it last? Did you do it? Did you do it? What's the release version? I don't know. Yeah? That's a part of our daily activity that we don't have to endure that with automation. Not only are we looking for the data, but it's the reuse of the data. If you're designing a new innovative product, the next generation of that product, you're looking for the person who had it last, the last release documents, the documents associated with the last release documents. I don't know. I spent most of my time when I was a petroleum engineer trying to figure out who developed the last nuclear reactor so I can figure out how to develop new gaffles. It was like a third of my day trying to collect all the data. And then now, in product development, there's more people outside of the nucleus of engineering that collaborate with us. Sales, marketing, procurement, other people that back in the day when it was a smaller organization, maybe we didn't have to mind those people so much because maybe they were us and maybe we were them. But now, it's grown into a metropolis of people, an ecosystem that really get product out the door. And unfortunately, all of those people depend on our information as engineers. We have to give screenshots to salespeople. We have to deliver documents and data for bill of materials. All of that's our responsibility. So this idea of lean design engineering or digital prototyping for best-in-class organizations has really arisen. But what does that mean, digital prototyping, lean design engineering? It's really melding all of those processes that we do traditionally in an automated form. We meld them together so I can conceptually design and test at the same time. So I can decide, oh, my first 100 ideas suck, and then my last 103, they're okay. Yeah? So, for this role play, my trusty PR engineer, and I'm going to be the mean engineering manager. So I'm going to turn it over to Omar.
Hi, my name is Omar Arriaga. I work for ABC Electronic Manufacturing. Our company produces electronic enclosures. Electronic enclosures for the aerospace industry. We have to comply with military specs as well as ISO standards.
I'm his microphone.
That's fine. Can you hear me? Can you hear me? Okay. So, what happens when there's a failure on the field? Like QA comes back and says, hey, this product failed the field. We need to have some type of changes.
Omar, hey, Quality Control sent you an email this morning. They created an engineering change request, and there was a field failure. I don't know what the reason is, but I'm your engineering manager, and you got to get back to me by the end of the day. How many know? Yeah, okay. Just make sure I'm in the same room.
Okay. So I got the email from QA saying, there's a failure. We need to revise it. We need to find out what happened. Okay. So the first thing I do when I have that test, I go into the vault to use out of this vault to find the data. Like Denee talked about how hard it is to find all the data, finding all the pieces together. Out of this vault, you can just do like a hard search number or keyword number or any type of advanced search that you can do to find all your data. And out within the files or the data are all the related documents, all the test data, or the drawing, the bill of materials. Is that all the data that I need?
Omar, also in the vault is all the history revision of who's had it before, what documents were associated with before. He didn't put ISO. ISO is really strict on documentation and steps related to ISO documentation. So we got to be able to house all of that information in one secure location, check it in and check it out, and that's what the vault does. It helps us design engineers with keywords related to, it can even be a part name, part number, whatever scheme that we decide. We search for that part name, part number, part scheme, whatever it is, and we determine not only the file, but everything associated with that file. The test data, the documentation, everything. There you go.
Okay, so Denee is correct. Not only I can find all the files, all the associated drawings, I could also see who was the last engineer that owned that project. I could have like a direct connection with them. I could, with DLM, I could send my email directly and have that connection back and forward, all within with DLM and all within the vault. Out of this vault has also an association with Outlook. So all those emails that go back and forward could be vaulted. And that history is there for like the vision to be part of the vision for like they say like the ISO components. Okay? So after I download my files, I start investigating what happened with that electronic enclosure. What was it really? Okay? So I started analyzing the pack data, and then I put that into an FEA analysis tool and try to find out if there was a migration problem. I keep going on up there, the migration is perfectly fine. And then I go into a CFD, and I run some analysis in CFD, and I notice there's some heat management issues. So before, we used to outsource that, right?
I was going to say, how many people here, their engineering manager says, hey, let's outsource that? Yeah, We outsourced this to a third-party engineer, and he couldn't find the recirculation issue. That's a concern. That's onus back on our company, back on my design engineers. Now, Omar's getting an issue from quality assurance saying, hey, you messed up. When in fact, Omar wasn't even here then. This was before we acquired the automated tools for analysis. So now that we have it, Omar's able to go in and check not only the heat issue control issues, but the full catastrophic failure. You said heat, test vibration. He can test things that typically as design engineers we may not want to go to. Just checking the safety factor isn't enough, my friends. We've got to go to the nth degree and figure out what's really wrong.
So, so after I run my CFD analysis, I noticed that there's an overheating. I keep doing some analysis and I'm making some design changes. And I noticed that by changing and by increasing the size of the heat sink, I'm able to get rid of that recirculation and I'm able to get that away from the overheating. So that's what I do. Using out of this simulation CFD Flex, I'm able to upload all those analysis up to the cloud. And then I can come back later, let's say after lunch, and get those results once I'm already done uploading them to the cloud. So I'll save it in. I'll get back to you after lunch with my results.
Hey, Omar, you better get back to me with the most cost-effective results, not just the best results. I don't want no expensive heat sinks. All right?
That's correct.
That's right.
So after lunch, I come back and I get all my results back from the cloud. Analyzing those results, I can see that increasing the heat and repositioning of the fans, I'm able to take away that heat that is causing the overheat. So after I'm satisfied with my results that I obtained back from the cloud, I can submit it to Denee for her approval and change the PCR that we got on the easel to this year.
So when he submits it back to the cloud, back to the vault, rather, the PLM automatically emails me as his engineering manager, says, listen, a change has been modified to this design. Then I can then open that email, check Omar's results, whatever he did in the validation tool, and this collaborative environment, I can automatically notify everybody in the ecosystem. Now that's the key important thing here. The PLM system manages my simulation results, it manages the history revision of every design change that I did, and it automatically enables me to notify the entire ecosystem of people and personnel that need that information. That's what's key here, guys. I don't have to run around with a thumb drive saying, oh, I made a design change, I made a design change, I made a design change. Everybody is automatically emailed and updated at the same time, right? That's what's important. Saving time, saving money, reducing that design cycle. That's what we're talking about. So just a little bit about some of the tools that we use today. Autodesk PLM 360, that was a tool that managed the conceptual model all the way to manufacturing. The Vault did all the complete history and revision control. Simulation on FEA and CFD was what we used to validate the problem and redesign. We did it in Inventor. Now, some of you may be thinking, Denee, I use SolidWorks. That's no problem, because guess what? Simulation is CAD agnostic. We don't care what you use, it's okay. I sing too. I'm available for vaudeville acts, later. Anyway, so the environment this ecosystem has created is really what's making me as a design engineer and able to do my job quicker, with less headache, and less people coming to my desk and saying, I need. Yeah? They can go to the PLM system and extract all the information they need. I can do my test and validation with my simulation tools. I can design with my Inventor CAD system, and I can manage the data with my Vault. That's housed within engineering. So, you may be asking, this may be new to a lot of people, because the Autodesk portfolio has really grown. So these are some of the ways the team and Autodesk can help you in throw your new product development system. If some of the things that we talked about today, you're doing manually, or you feel like some of the things are antiquated at your company, please come talk to us, because all of these breadth of tools are available to you as our customer base. I thank you guys. That was the end of the most awesome presentation of the day. Give your eyes a hand.
Yeah!
All right. First time. Okay, who can name for me the name of the PLM tool that we use for the presentation? Pay attention. Focus. Everybody focus. All right. What CAD tool do we use?
Autodesk what?
Autodesk what?
Product
He starts with an I.
Inventor.
Oh, damn. Okay, I guess you get two water bottles. Give me another one, man.
Thank you very much, guys.